So when you're looking at a piecewise function, it's very important that you recognize what the domain is. So if we're going to go ahead and start out, and if I go ahead and ask you to find f of -1, which of the three portions? We have the top portion, the first condition, if x is less than 0. We have the second condition when x is equal to 0. And finally, we have the third condition when x is greater than 0. So what I have here is I'm asked to find this when x is equal to -1. That's what that function means. So because of that, that's less than 0. That means I plug this into the first piece. So what is -1 to the third power? That is just going to equal -1. If I want to go ahead and continue this and say what happens when f of 0, well, that just means this whole thing is equal to 4. Now, why was it 4? Again, that's that blue section that I have up here. When x is equal to 0, my function y is equal to 4. And the last one we'll do with this one is what happens if f was equal to 1. Well, that is in that third one, the one I highlighted in purple. So that is just your 1 squared plus 5. So f of 1 is equal to 6. If you need to write this as a point, because all of these would be points on your graph, your first value here would be -1, -1, 0, 4, and finally 1, 6 for the piecewise function. Now, to graph a piecewise function, it's really important that you first recognize the fact what you have. So let's go ahead, and in this graph, I already have the outlines of a few different things, but we're going to look at the first one that I have here, which is y is equal to -x squared plus 6. All right, that gives me a parabola going down. And my value right here is going to be 0, 6 for my vertex. Now, the thing of it is with this, it says x must be less than -2. So when you're thinking about this, the domain, your x values, they start at -2, even though that this particular point is not included. And then those values are getting smaller. X must be less than this. So another value would be -3 or -4. When you plug those values in, make sure you realize that you're plugging in that negative and it's going to be squared, but there's a negative on the outside. So what I mean by that, that would be -2 squared plus 6, which is -4 plus 6. So that gives us a +2. Now this point is not included. So that means over here on this particular piece, I'm going to draw an open circle around where that parabola is. And then as we're going down, if I plug in -3 and -4, you'll go ahead and get -3 and -10, which would be off our graph. So -3, -3 is going to be here. Go over -3, down 3, and -4, 10. So this is the portion of that graph that is this part. And that does keep going down. All right, the next one I'm going to do is the absolute value of x. That is just a V-shaped graph centered about the origin at 0, 0. Now the thing with this graph is this only has a domain where x is between -2 and 3, where the -2 is included. So at -2, all the absolute value of an equation does is turn that positive, so that would be -2, 2. And again, this is included, so you fill that circle in, this point is included. And you know it is included because you are using the less than or equal to. So that's going to fill that circle in for me right here. And then I'm going to come down and then go up to -3. Excuse me, go up to a +3, which is 3, 3, which is going to be up here. So I'm going to go ahead and continue that and go all the way up to 3, 3. But at 3, that would be an open circle. And then the last one I'm going to do is my line. And the line that I have for this is 2x minus 5. Again, the domain for this, x must be greater than or equal to 3. So I can go ahead and start with 3 here. This point is included, so it is a solid circle. If I plug 3 into that piece, I get 2 times 3, 6 minus 5, which gives me a 3, 1. And the next point I want to pick in there is 5, 5. If I plug 5 in, 2 times 5 is 10, 10 minus 5 gives me 5. So then I'm going to come up here and go over to the 1, 2, 3, 4, 5, up. My point will be right there. And that continues going in that direction. Now, in this graph, I had already had the outline on the background. We're going to do one more where that's not the case. So again, always think about piecewise functions as 2 separate parts. So let's go ahead and start the first one. The first one is x squared when x is between -2 and 1, and neither of those values are included. Now, I know the shape of this graph is a parabola at the origin going up like this. Now, what happens though at the endpoints of that domain? What happens when x is -2? And again, we're just going to put 0, 0 in there because I know that's going to be a point on my parabola. And then what happens at 1? Now remember, both of these are open circles. Make sure you see that that point isn't actually included, but we need to know what happens at the endpoints of those domains. So if I plug in -2, you are going to get a +4. If you plug in 1, you will get 1. So we're going to come over to those graphs and make those. So I'm going to go over here at -2 and go up 4. And I'm going to make my open circle. I know my parabola has a point 0, 0 on it. And my last point is going to be 1, 1, which again will be an open circle. So my parabola will have this shape, but the endpoints of that both will be open. Now the second portion of this graph has it being a line. My line here is y is equal to x minus 5. And my domain here goes from 1, which is included, up to 4. So what's going on with this line? All right, so what happens when x is 1 and this is an included point. I just plug that in, and I'm going to go ahead and get out the value of -4. And if I plug in 4, I will go ahead and get a value out of a -1. Now this is an open circle because it is not included. So let's go ahead at 1, -4. I will have that included circle. And this graph is going up to 4, 1, which is an open circle. So this one would be the final graph of our piecewise function.